Good day, my dear students. Welcome back to our General Mathematics lecture series. Our focus today is the continuation of what we discussed series number 6, that is on the one-to-one function. Okay? Once again, I'm Agi, your teacher in General Mathematics of Gisad Valley National High School. Before we're going to start, may I invite you to please click subscribe button and the notification bell so that if I will be posting a new lesson, you will always be notified. So, once again, smile, do not be serious, fasten your seatbelt, and relax because you can always beat this general mathematics. Our focus today are the properties of a one-to-one function. So, the number one property is that the domain of the function equals the range of the inverse function, and the range of the function equals the domain of the inverse function. Now, how is that? That will only speaks of one-to-one correspondence, meaning to say, if I have two domain, there must be, of course, two range. At the same time, if I'm going to get the reverse, that range will equals the number of the domain. Another one in here is the composite of inverse function of f of x equals x for every x in the domain. The number 3 properties is that the graph of a function and the graph of its inverse are symmetric with respect to the line y, which is equal to x. So again, the graph of a function and the graph of its inverse are symmetric with respect to the line y, which is equal to. To understand these properties, I will all explain them using a given illustration in the next slide that I will be showing. The ordered pairs of the function f are reversed to produce the ordered pair of the inverse relation or the function. This speaks of the property number 1. Now, given the function f, my coordinates are the following: 1a, 2b, 3c, 4d. You notice that my domains are the numbers and my range are the alphabets. So you notice also that I have in here a one-to-one correspondence. You notice that the domains are the numbers and my range are the alphabets. And you will also notice that I have in here a one-to-one correspondence, meaning to say I have one number, one alphabet, one another number, another alphabet, another number, another alphabet. You will notice that my numbers are not repeated and my alphabets are not repeated. This speaks of a property number 1. Okay, so there is the one-to-one correspondence between my coordinates. The inverse relation of the original function is just the reverse of the domain and range. I just interchange the numerical and the alphabets. So I have in here the coordinates of my inverse function. I have a1, b2, 3c, d4. Okay. Another in here is the domain of the inverse function is the range of the original function, and vice versa. As it says in here, the range of the inverse function is the domain of the original function. The graph of a relation and its inverse are reflection in the line y is equal to x. What do we mean by this? Consider this problem. Find the graph of the inverse relation geometrically from the graph of the function x raised to 3. You notice that when we are going to look into the graph of this inverse relation, definitely what we are trying to illustrate is the reflection of the original function. What is the original function? F of x is equal to x raised to 3. So meaning, when we are going to look for its reflection, we have to see to it first that we have to plot this original function. So before we're going to plot, again, the domain of these cubic functions are all real number. There is no restriction. And so I can just assume values of x. Let's move on. Here are my values of x. So 2, 1, 0, negative 1, negative 2. And so what if, and so if my x is positive 2, then my y or f of x must be 8. That is the same as 2 raised to 3 will give me a result of 8. What about if my x is 1? My y would be 1 raised to 3 will always give me a result of 1. At the same time, if my x is 0, my y will always be 0, or shall I say 0 raised to 3 will give me a result of 0. If my x is negative 1, my f of x or y will always be negative 1. At the same time, if my x is negative 2, my y will be negative 8. And so we are now ready to graph or plot these coordinates. Okay, so here is the graph of the cubic function x raised to 3. So if I have x and 8, the location would be in here. So here is my x, which is 2, and my y, which is 8. So my point is located in here. What about if my x is 1? So I have in here my 1. So my point will be located in here. As you can see, it corresponds to my y, which is also positive 1. Now you will notice that this graph passes through the point of origin, which is 0 and 0, and it will pass through the negative 1, negative 1, and negative 2, negative 8. So this is the graph of my cubic function. Now, to get the reflection of this original function, of course, we have to compute, or we have to look for the inverse of this cubic function x raised to 3. So the cubic function x raised to 3 has an inverse form of f of x is equal to the cube root of x. So this is the inverse function of my f of x is equal to x raised to 3. What is its inverse? F of x is equal to the cube root of x. Again, our focus is to see the reflection of f of x is equal to x raised to 3, and so we have to use this one. Okay, before we're going to plot this one to see the reflection of the original function, we have to again assume values for x. And my values for x are the following. You notice that I just interchanged the range and the domain. The element of the domains and the element of the range. That is according to property number 1. Okay? So I just interchanged them. Now you will notice that when my x is 8, I have to get the cube root of that x. It will give me a result of 2. At the same time, if I have a value for x which is 1, now the cube root of 1 will give me 1. Follow the same pattern. So if I have x to be 0, my f of x will be 0. If I have negative 1, my f of x will be negative 1. If I have negative 8, the cube root of negative 8 is negative 2. So I have a value for my x which is 8. My y will be 2. So you will notice my 8 is located in here between 5 and of course between 5 and 10. So my 8 is located in here. And so we are now ready to plot the points. So consider this one. And going up, my point is located in here. Notice that this is my point which also correspond to my y positive 2. So y positive 2, yan, x is positive 8. It will follow that if I have 1, 1 as my coordinates, so my point is located in here. So this is my point which correspond to my x, which is 1, and at the same time my y correspond to 1. So it will pass through the point of origin in here, now going down, and negative 1, and at the same time it will be this point which is which correspond to negative 2 as my y and negative 8 as my x. Now you notice that when we are going to put this one in a Cartesian plane, it will give you a result, or it will be like this one. Okay, so ayan, this is my the graph of my inverse function. What is my inverse function? I have in here f of x is equal to the cube root of x. Where is my original function? F of x is equal to x raised to 3. Now it says in here the inverse are reflection, the graph of the inverse is the reflection of the original function. So that is, you will notice I have this one. Okay, so here is my line y which is equal to x, original function. Okay, this is the graph of my original function. And another one would be, you notice that this color is the reflection of this blue one, or this blue one is the reflection of this original function. The graph with the color blue is actually the reflection of this graph. The graph of f of x, which is equal to x raised to 3, is the blue one, which is the inverse f of x is equal to the cube root of x. Now, it says in here, determine the inverse of a relation algebraically. Okay, so I have in here, find the inverse algebraically for the function f of x, which is equal to 2x plus 1. 2x plus 1. So how is this? Meaning to say, we are going to look for its inverse. And so how are we going to look for the inverse of this function? Consider these following steps. Okay? You notice that when I'm going to get the inverse of this function, I have to copy the original equation or function. Okay? So here is my original function, 2x plus 1 is equal to f of x, or shall I say y. After having now this original function, I will interchange the position of x and y. So I have in here now a new statement, x is equal to 2y plus 1. To continue, solve for y after interchanging the position of your x and y. And so when I'm going to solve, I have now in here a new statement. You will notice I have x minus 1 is equal to 2y. What did I do? I use the concept of, you will notice that I have x minus, you will notice that I have x minus 1 is equal to 2y. Now, how is that? You notice that I subtracted in here minus 1, and at the same time, at the other side, I subtracted minus 1. That is according to the property of addition, property of equality. So having said that, you notice that we are looking for the value of y, and so what did I do? I divided both sides of the equation by 2. So 2y divided by 2, and that is the same as x minus 1 divided by 2. And so I have now in here a result, 2y divided by 2 will give me a result of y, and at the same time x minus 1 divided by 2 is the same as x minus 1 divided by 2. And so I have in here now the inverse of the original function. So that is my inverse. Yan. So what's my inverse? The inverse function is equal to x minus 1 over 2. So that is how to get the inverse of the original function. Again, do not forget to study these steps, because you will always consider this process when we are going to look for the inverse of any function. Let's move on. To calculate a value for the inverse function, subtract 1 from x and divided by 2. Having said that, we have another in here. The graph of the function f of x is equal to 2x plus 1, and its inverse is in here. So I have in here the graph of the original function, the blue one. Okay, so this is the graph of f of x is equal to 2x plus 1. And what about the inverse? The graph of the inverse is, we have the red broken line. So ayan, as I said, that is the original function, and that is the graph of the inverse function. This graph is the reflection of my original function, or vice versa. Before I end this lecture, I hope I shared to you ideas about one-to-one function in my humble capacity. Okay, please like, click subscribe, and click the notification bell so that you will always be notified if there is a new lesson posted. Once again, thank you for listening.